Some of you picked it up yesterday, but others of you didn't. So I just want to go over it briefly, how we factor these special patterns, because one of them is going to come into play the second half of chapter 1. You'll have to be able to recognize it. I'll do the easy one first. The first one, we call it a difference of two squares. So difference means what? Subtract, right? And a square, when I'm talking about a number, is what? What does it mean to be a perfect square? That's right. It's something times itself gives you that number, okay? So give me some examples of perfect squares. 16, 9, 4, times 2 is 4, 36, 1. Those are all perfect squares. What if I said x squared? Is that a perfect square? Yeah. X is the square root, so yes, x times x is x squared. So when you see these two things, okay, separated by a subtraction sign, and that's the key, it's got to be subtraction sign. I'm going to use a different one. Okay? If this was plus, it wouldn't work. It only works because it's subtraction. It factors. Now remember, I could set this up and I could slash it and find the factors, but it's easy because it follows a pattern. You do the square root of the first, minus the square root of the second, and then you do the same thing with a plus. Easy? Every time you see two perfect squares with a minus in the middle. Can y'all remember that? You just do that. That's it. That's instead of, I could come here and you don't have to write this, and go negative 81. What multiplies to negative 81 but adds to 0? And it would be 9 and negative 9. So plus 9x minus 9x. Then I could slash it. But the point is, what I would come back to is this. So it's a shortcut. Yeah. So it's a shortcut. So look for those shortcuts when you can see them. Little bit harder one is what we call the perfect square trinomial. You need me to go back?
Write it down.
Perfect square trinomial. Trinomial means it has 3 pieces. Okay? And there's a couple other stipulations that have to happen for it to be a perfect square trinomial. The hardest part about this one is recognizing that it is a perfect square trinomial. So here's the criteria. The second sign has to be a plus. The ends have to be perfect squares. And then the hardest part about it is whatever sits in the middle, it has to do what Miss Wilson and I call square dancing. If you take the square root of this one, what do you get? If you take the square root of this one, what do you get? If you multiply those and double it, it has to double. That has to be what's in the middle. Okay? Square, square, multiply and double. Square, square, multiply and double. If that's not like that, it's not a perfect square trinomial. Now, I'm missing something. It could be either plus or minus, okay? It doesn't matter what's there. What you do, I'll start with a plus. Let's just do plus. Whatever that first sign is how it factors. So for this one, come on, it would be x, the first sign, 6 squared.
Wait, what made you put the plus in?
The first sign's a plus. If the original one had been x squared minus 12x plus 36, it would be x minus 6 squared. Okay? You can still factor it like normal. It's not that big of a deal. But whenever we get to a couple things, these numbers can get really big really fast. So it's good to recognize the pattern. But when we start completing the square, you'll have to know the pattern. Right. So let me show you one that's got a negative. Let's say it was... Is that a perfect square trinomial? Yes or no?
Yes.
Why? 3 things. Second times plus. The ends. Perfect squares. Does it square hands?
Yes.
Yes. X times 5 doubled gives you 10x. So this one would factor. You tell me, how does it factor? Square. That's it. Easy? All right, let's do the new stuff. All right, guys, I'm seeing phones out and stuff. Let's put everything away. The new stuff, it's just one little teeny little extra piece. I think you'll find it pretty easy. Let me set up a scenario for you. Y'all ready? I know it's Friday afternoon. Y'all are tired. Me too. I got 2 things multiplied together. Yes?
Yeah.
They equal 0. What do you know? Without me telling you anything else, tell me what you know has to be true.
One of those numbers is a 0.
One of them has to be 0. There's no other way to get 0 when you multiply this. One or both are 0, right? That's the property that we're going to use. It's called the zero product property, but it's a really simple concept. It says if 2 or more things are multiplied together to give you 0, then either this must be 0 and or this must be 0. So this comes into play with our factoring when we're solving. Remember yesterday you had those few that were equal to 0 and I said just scratch the 0 out and factor it? What if you had something, what, do I need to wait just a second? Y'all got it? Y'all are zombies today. You need me to go back? Let's say I had this factored like this. I've already done my whole factoring deal, right? But it equals 0. What operation is happening between the 2 parentheses? Everybody agrees that's multiplication? That's what factors are. Factors multiply together. So this is multiply. So do you agree that I have 2 things multiplied together, thing 1 and thing 2, to give me 0? So then would you also agree that either this or this has to be 0? So set them to 0. Exactly. Solve each one. I didn't mean to do that. I have 2 answers. Okay, so when you solve these, you get 2 answers. Now, this was already set up for you in nice factored form. Of course, you'll have to factor it and then set each piece to 0. Okay, so this is the new part. That's not a lot, right? Setting each piece to 0. So we're going to do one start to finish. Let's do an example. I'm going to run you some steps here too so you know. So this is factor and solve. Guys, I need your attention up front, please. 3x squared plus 10x minus 8 equals 0. So the first thing you want to do, and this one's already there, is you want to make sure it equals 0 because that zero product property is only going to work if they equal 0. So make it equal 0. In this case, it already equals 0, so I'm good to go from there. That makes sense to everybody so far? If I had something on the other side, I'd need to move it back over. So now I need to factor. Everybody's favorite, right?
Nope.
Come on now. I got to factor this. What is A? How about B? And C? Multiply the first and the last together. What do you get? Negative 24. What 2 things multiply to negative 24 but add to positive 10? I hear 6 and 4, but that's that. If they're both negative, they're going to multiply to positive, though. You got it. Negative 2 and 12. Good job. I told y'all that's the hardest part, right? It's got to multiply to, if you ever see it's got to multiply to a negative, you got to have one positive, one negative. All right, so from there, those are my two middle terms now. So I got 3x squared minus 2x plus 12x minus 8. You got it, David. Cut it in half. How about the first two? What can you take out of those two?
1x.
1x. You can't take 2 out because you can't divide 3 by 2, and you can't take 2 out because you can't divide 3 by 2. So I just take an x. What's left? 3x minus 2. Y'all with me? Middle sign. What can you take out of the next two? 8. You can't take 8 because 12, you can't divide 12 by 8. 4. You're not dumb, David. Don't you say that. What if you divide both of them by 4, what is left? 3x minus 2. How do you factor from here? What do you take out? What are the parentheses? So 3x minus 2. What's left? X plus 4. Nothing new still, right? We're still same thing we were doing. Now I need to solve it for x. So to solve it for x, I need to get rid of these updates. My computer's it's going to take forever to update when I finally do. So now at this point, you want to set each piece equal to 0 and solve them individually. So set each parenthesis equal to 0 and solve. First parenthesis, 3x minus 2. Second parenthesis, x plus 4. How do you solve the first one? What do you do? Add 2. Now what? How do you get it? Divide by 3. One of the answers is 2/3. How about the other side there? It's minus 4. The other answer, so we're looking for 2 answers when we do this. Does that make sense? I want to run through one more with you where it's not equal to 0 to start with and see what we do from there. I'm not going anywhere.
This is more like what we did the day before. Right?
Yes. It definitely is. Let's do this one. (5x squared minus 14x equals 3. 3. What do I need to do first to solve this? Take away the 3. Remember, one side has to be 0. A good rule of thumb also is to always leave that x squared positive, if you're wondering which way to move. All right, I've got a quadratic equal to 0. I'm ready to solve. What do I do? Y'all are out here ABC and multiply. You're both right. It's okay. I'll get it in a minute, Grayson. We're factoring, right? Right. So A is what? What about B? and C. When you multiply A and C together, what do you get? What multiplies to negative 15 but adds to negative 14? I heard, yeah, negative 15 and 1. Does that confuse anybody? All right, let's set up our equation then. 5x squared minus 15x plus 1x minus 3 equals 0. Slash, cut it in half. What can you take out of the first two pieces? 5x. What's left? Divide, not subtract. Minus 3. That's right. Ooh, what can I take out of the second two? 1. Somebody said 1. Very good. When there's nothing to take, take a 1. And everything else stays the same. You all right, Joe?
No, I was just saying it's kind of smoothed out, it just stays the same.
Yeah.
Take out the
Now what? How does it factor? What goes in front? X minus 3. What's left? Am I going too fast? Y'all sure? All right. Everybody goes to 0. The x minus 3 and the 5x plus 1. How you solve the first one? You got it. How about the second one? Minus 1. These are simple little, they won't be more than 2-step equations like this. And divide by 5. What do you think about the solving portion? Gives you more factoring practice, okay? But the only additional thing is we're setting each piece to 0 and solving, okay? Just make sure it equals 0 before you start.